Hi, thanks Alexi. Thanks for having us here. As he said, I'm from Mesosphere. How many people have heard of Mesosphere? Yeah, that's pretty cool. Okay, so just a little brief history on Mesosphere. Mesosphere, the M in SMAC is what the company was formed on. We actually build a distributed cloud-based operating system. What does that mean? That means that we treat your data centers, whether they be on the edge, in the core, or in the cloud, and make it look like one virtual data center, if you will. And that allows you to take your workloads and deploy them anywhere and manage them. And that's essentially what DCOS is. So that's what I'm going to talk about. I'm going to hit next, and he's going to go there. So if you take a look at just what's happening with data, and I'm just using this as an example. You could apply this to healthcare, but I'm using the connected car example here. You can see the amount of data that's being generated. I think there was an article that was posted. There was 4 terabytes of data per car per day. Right, that's a lot of data to ingest, and that data comes from all kinds of pieces of information, and they come into somewhere that gets processed. Where do they get processed? Where do they live? How does it actually happen? And that can happen at the edge. You can have, like we have a customer that actually has data centers on ships, right? They're mobile. The data centers are actually moving. Most people, when they think about a data center, they think about it as being fixed in a building somewhere, right? And we don't think about it that way. We think about data centers can be very, very small. They can be mobile. They're in airplanes. There are smaller versions. And they're going to be in cars, in trunks of cars that are processing tons and tons of data and making decisions in real time. That's where machine learning comes in. That's where AI comes in, to take all of this data and to be able to then use the information to actually make decisions. So this is the one example that we're talking about, but there can be other examples as well. Hit the next button. So what we try to think about it, because we're a platform company fundamentally, we want to enable SMAC Stack and want to make it really, really easy. That's our mission. Our mission is to make this SMAC Stack extremely easy, to build it and deploy it at scale. So we allow people now in our platform to be able to deploy any one of these big data services with basically one click or one command. Right? You don't need expertise to do this. You also don't need expertise to upgrade, maintain, manage it, monitor it, all of those things that changes the game when you have it in a single silo or a single place. When you have it in a cloud-based operating system, then those challenges are quite difficult to handle, but we try to make that really, really simple, and that's our mission, and that's what we're trying to do here. Deploying each data service is extremely time-consuming. And we try to address that. It takes a lot of people to do that. Also, operating this thing is extremely error-prone. So we now have the SDK, which allows people to build, like Lightbend is one of our partners. So we actually build Spark, Cassandra, Kafka. All of these things are built on the SDK, so we handle all the upgrades, all the maintenance while those things are running. So you could upgrade from one version of Kafka to another version of Kafka, or you could downgrade. Right? It's pretty straightforward and pretty simple. And as you know, Cassandra, Kafka, they have their own way of doing those things, but we enable that. The other benefit that we have in the platform is to make sure that these big data services and stateless applications that have to use these services the developers are building, they can run on the same shared infrastructure. And that's important because the resources that you need, today if you think about the way people use VMs, it's like very lightly used. We try to make sure that those resources are like, you get to 60, 70% utilization rather than 5 to 10, which is what's on average. When we think about resources, we think about all the resources in isolation. So if you think about CPU, memory, disk, network, volumes, as well as GPUs, and eventually it'll be TPUs as well if Google gets, Google's working on those things. So because we deploy in any infrastructure, it doesn't really matter whether it's Amazon, Azure, or Google, because you can move your workloads easily if you're running it on DCOS, then we can take advantage of those specific resources. You can have a Spark job scheduled to use the GPU. Like we actually support NVIDIA's GPU out of the box. It's available within DCOS. So you can take a job and say, I want to run it on these nodes that actually have the GPU running, and you can schedule the jobs on GPUs. And those resources are shared across your entire infrastructure. Okay? that's our goal, that's our mission, that's what we try to do. We want to make the deployment really, really, really simple. So all of the Smack stack that you can think of is basically one-click install. It's a tile, install it, it will start running. Okay. That's how simple it is today. All the upgrades, the operations are metrics management. You can write to statsd, push all the metrics to statsd. We are the producer of those metrics, so we take all the infrastructure metrics as well as enable people to push the metrics through DCOS, and then you can consume it anyway. We can use the same Kafka to consume the metrics through Kafka, and then Kafka can send it out to Prometheus or Elastic somewhere else that it can go. So your end consumption can be different, but we produce all the metrics and we allow you to run those metrics infrastructure out of the box. Same with the logging infrastructure is out of the box. And this is the advantage of having both stateless containerized apps as well as stateful applications running on the same shared infrastructure with same shared resources. The other thing we're also working on in terms of resource utilization is to make sure that we can optimize for these big data workloads. So if you have Spark and wants to schedule a job on a GPU, or if you're scheduling a job on a set of resources, you can also prioritize these things. You can have reservation quotas for a particular type of streaming jobs, okay? Or any type of big data services that you want to do. So Lightbend will talk more about that. As I mentioned, NVIDIA is something we support already out of the box, so you can now see which jobs are running on the GPU, and you can decide that I want to run this particular job or this particular task or this particular workload and leverage the node that has GPUs there. You can actually schedule it on that specific node. So that allows you to take your workloads. If you need GPU services, then you can do that. Obviously, if every node has the GPU services, then we make it look like one giant pool of GPU services, GPU shares that are available to you. The one difference between CPU and GPU is that today, if you want to run a job, you're going to take the whole GPU, where CPU can actually do it in shares. So if I have 1,000 nodes, and I don't know how many ever cores there are, we think about them as CPU shares, and the workload gets shared among all of these CPUs. But if you're running a GPU, you'll say, okay, I want to run this job on this particular set of nodes. That these are the only nodes. 10 out of 1,000 have GPUs in them, and you want to pin it to that. You will pin it to that, but then you're going to use that whole GPU. You can't like cut the share, take the shares of the GPU. But once we can work with NVIDIA and partners to make that better, then we can also have that available as shares. Okay. So this is what we're trying to do. We want to make sure that we're providing data-rich applications here with the Smack Stack, and we are the platform provider. So we allow you to run all of these things out of the box. These are all available today, so no reason to worry about it. You can hit the next one. And that's it. Thank you.